proceed flux will proceed flux density in calculus. Flux density we have calculated. Flux density flux density is nothing but flux surface integral through a surface integral through a surface integral through a closed surface divided by volume generated by the closed surface. That is called flux density. Flux density in bigger term divergence. Flux density divergence. What is surface integral? If I have a surface and if I have a vector, if I have a surface, if I have a vector, then vector multiplied by the surface. That is surface integral. A vector multiplied by a surface. If vector represents a velocity, velocity into surface will give me volume coming out of the surface per second. Per second. That is the flux. If I have magnetic field, if I have electric field, if I have electromagnetic field, then how much it is if there is a magnetic field and passing through a surface, what is the flux of the magnetic field? What is that? If I say volume per second, so better there is a liquid that is passing through a surface, then how much liquid is passing through the surface per second? Volume per second. Velocity of the liquid is meter per second and surface is meter square. If you multiply, it becomes meter cube divided by second. So volume, how much is the volume that is coming out of the surface? How much is the volume that is coming out of the surface? This is flux density. This is flux. If surface is closed one. So this is surface closed one. So this is a sphere. Actually, it is not a sphere. It was a flat surface. Then someone molded it and it becomes a closed surface. This is a closed surface. It has it has no opening anywhere. So there is no line integral possible. This is a closed surface. If this is a closed surface, then what about surface integral? Then if there is a vector field is algebraic vector. If I have a vector 2i plus 3j, this is called numeric vector, static vector. If I have a vector that is x plus yi plus x plus sin yj, then it is called algebraic vector which components are algebra. If that is the case, then it is called vector field. What about area? Area is a flat, then this is the area. If area is flat, then this is area direction. What about area is like this? If that is the case, then area vector is like this. So the surface integral is nothing but area vector is also vector field. Vector field means if you keep changing x and y independent variable, then vector would start changing its strength, its direction. So many people say it is a function, vector field is a function where the parameter to the function are independent x and y and it keep producing different static vectors. A vector factory, that is a vector field, whatever it is. Now, if I have a surface, closed surface, and if there is a vector, if this is a closed surface and there is a vector field, then vector field multiplied by the full surface. Okay, looks little awesome, looks little awkward, but this is now we come to calculus. So capital F vector, that is vector field dot capital F vector dot dA vector. integral over full surface is the flux divided by volume of this sphere is the flux density. What we saw that if flux source, the vector field source is outside and it is coming and it is passing through the surface, this closed surface, then net flux density of this vector field inside this volume is 0. 0 means that there is no source inside this volume. This volume, what we are seeing, inside this, there should be a source which is generating the vector field. Vector field is generated by a source that is somewhere else. From that source, vector field is coming and it is passing this surface and passing away. If I divide this sphere in this is the line and left side and right side, the left side whatever the surface integral is coming, right side whatever surface integral is coming, one will be positive, one will be equally negative. If that is the case, then surface integral itself will be 0. So the the divergence or flux density, surface integral divided by volume, would be 0. So 0 means the source of vector field is outside. It should be inside. It should be inside. Then the flux density would be positive, divergence should be positive. Divergence, energy is diverging from a single point. That is divergence. But that energy source is outside. There is no divergence inside it. The energy which is generating the vector field, it should be inside the volume. Then only divergence will be positive. If there is a point, rather than diverging some energy, it is absorbing energy and it is inside the volume, then divergence is negative. Okay, like I give example like black hole, divergence is there but negative direction. Sun, divergence is there and in positive direction. Earth, divergence is 0, sunlight comes and it passes through, or rather I can say little negative because it absorbs few part of it, whatever it is. But this is the story of divergence. So divergence, we are calculating in a phase of calculation. What is divergence? Surface integral divided by volume. Volume tends to 0. The volume tends to 0. Means rather than taking a sphere, consider that I am pressing this sphere and it is becoming small, and it is becoming a small point. What is small point? Then surface integral along the small point surface divided by the volume. That is divergence. In other words, that small point should radiate energy. That's it. Then divergence is positive or it absorbs energy, divergence is negative. But energy source is outside and it is just passing through, divergence would be 0. Okay, one example I gave one example I have taken like ZK. If you remember ZK, if this is XY plane and consider this is XY plane. If this is XY plane, then this sphere is centered. This is the origin of the XY plane. This sphere is centered at the origin. Right now it is sitting on top of origin. So piercing at the center and it goes inside and it is centered at the origin. Now it has two hemispheres. One is above XY plane, one is below XY plane. Above and below xy plane. Consider a vector field zk. A vector field is passing through. So it is passing like this. So above the xy plane, the equation of vector field is zk. Below xy plane, equation of vector field is minus zk. So that again it will be in same direction. Zk means if I go along above the xy plane, it is positive. But if it is minus zk below the xy plane, then if I go along, it will be again positive. Okay, but power will go down. At origin, power will be 0. Again power, so power would decrease till xy plane and power would increase, whatever. Its direction is like this. If there is a sphere centered at the origin, then what is its flux density? That is the question. What is its flux density? Then if that is the case, what is its flux density? Then what is flux? So if I take top hemisphere, then zk capital F vector dot dA vector is the flux density. So capital F vector, I have calculated it. So capital F vector flux density. So capital F vector is zk and dA vector for spherical coordinate system is cos phi sine theta I plus sine phi cos theta I plus sine phi sine theta j plus cos phi k, and that side it is a sine phi d theta a d phi. This big is the a vector. Now zk, if I do dot product, everything will go away, cos phi k will remain. So z cos phi and then a sine phi d theta a d phi. Now is a z is a cos phi. So a cos phi a a to the power 3 I can keep outside and it becomes cos square phi sine phi d theta. If that is the case, then integration of cos square phi sine phi is minus cos to the power 3 phi by 3. If that is the case, then now I have to place limit. So limit is now phi is 0 to pi by 2. Top hemisphere I am taking 0 to pi by 2. 0 to pi by 2 will resolve in 1 minus 1 by 3. So minus minus gone 1 by 3. D theta integration over xy plane is 2 pi. So now it is 2 pi a to the power 3 by 3. Okay, 2 to the power 2 pi a to the power 3 by 3 is the flux. That is upper hemisphere. What about lower hemisphere? It is minus zk, same thing, minus k. So it will be minus 2 pi a to the power 3 by 3. For the full sphere, it will be 0. If flux is 0, then flux density would be 0. So, if there is a vector field that is passing through the sphere, then there is no flux density. But what about the vector field is r vector? R vector, if it is kept at origin, then r vector. If it is kept at origin, then r vector. So, the r is inside it kept at the origin and r vector is the vector field. If that is the case, then r vector would be perpendicular to all everywhere of the surface. If that is the case, then vector field capital F dot dA vector, where dot is always parallel to the area vector. So dot fundamental went away and it is R. It is R and then dA. So full area, if I take, since dot product went away, I can directly compute it. So it is R into 4 pi R square. R into 4 pi R square, that is the surface area. That is the flux. It is positive. If you see, for the full sphere, if I keep the a source at the center where it is centered at the origin, if I keep a source, energy source, and the vector field for it is r vector, then it is going all the way and it is crossing a sphere where it is parallel to the area vector. So now the surface integral is 4 pi a square into r vector means a divided by the volume of the sphere, then it is flux density or divergence. What is the power? If I take this sphere bigger, 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 because flux density is coming, that is 4 pi a to the power 3. That is the flux density that we are seeing. Where a, if I make the sphere bigger, the flux would be bigger, bigger, bigger. But that is not giving the nature of the source that is kept at the center. If you want nature of the source, divide it by volume. That will give the divergence. If I have a vector field source kept at the center, it has divergence. What is the flux multiplied by the area? So that I'm not looking for. I am looking for what is the power of that source. Then flux divided by volume of the surface through which I calculated the flux. Then it is 4 pi a to the power 3 by volume of a sphere is 4 by 3 pi a to the power 3. Everything gone, 3 will go up 3. 3, 3 is the divergence of this divergence source. If you remember, I deduced a formula to calculate. This is called geometric way of calculating the divergence. There is another way called algebraic way or Cartesian way. That is df1 by dx plus df2 by dy plus df3 by dz. If you just add it, you get the divergence. Divergence is not a vector. It is just a power of radiating all along. What is the divergence of sun? Is there any vector? Just it talks about the field, power field that is generating all around. Doesn't matter. It is omni. So only the magnitude matters. No one talks about sun vector field. Only what is the power of the sun? What is the divergence of the sun? If that is the case, then now if I try to calculate divergence, what is the r vector? Xi plus yj plus zk. That is the r vector. F1, if this is a vector field, xi plus yj plus zk is the vector field, then F1 is x, F2 is y, and F3 is z. df1 by dx is 1, df2 by dy is 1, df3 by dz is 1, total addition 3. So simple, right? Divergence, calculating the surface integral divided by the volume. This method is called geometric way, whereas Cartesian way or algebraic way calculating is df1 by dx plus df2 by dy plus df3 by dz, and here it is 1 plus 1 plus 1, 3. What is the divergence of a vector r vector divided by magnitude of r to the power p? This is a very famous question. What is the divergence, that is r vector divided by r to the magnitude of r to the power p? P for pointer. R vector divided by magnitude of r power p. What is divergence? Divergence means if this is the vector field, this is the vector field, r vector divided by r to the power p. If this is the vector field, then I have to keep this vector field source at origin and take a sphere, cube, whatever, calculate the surface integral, divide it by the volume. If that is the case, then only we can calculate the net flux density or divergence. But we can go with the df1 by dx plus df2 by dy plus df3 by dz. Now here r vector is xi plus yj plus zk divided by r to the power p, where magnitude of r is x square plus y square plus z square to the power 1 by 2 to the power p. So it is xi plus yj plus zk divided by in braces x square plus y square plus z square to the power p by 2. Now, if I calculate df1 by dx, then first I shall keep the numerator and take the differentiation of the denominator. So it will be x multiplied by minus 3x divided by x square plus y square plus z square to the power p by 2 plus 1. You can try. So it will become minus 3x square divided by x square plus y square plus z square p by 2 plus 1. Now I'll do differentiation of the numerator, keeping it like this. So it will become 1 by x square plus y square plus z square to the power p by 2. Now if I settle it down, it becomes minus 3x square plus x square plus y square plus z square divided by x square plus y square plus z square to the power p by 2 plus 1. Now if I do this df2 by dy plus df3 by dz, then all along we'll get minus 3x square plus x square plus y square plus z square plus minus 3y square plus x square plus y square plus z square plus minus 3z square plus x square plus y square plus z square divided by x square plus y square plus z square to the power p by 2 plus 1. Okay, if I am not making any mistake, I am making a mistake. Okay, I believe that I calculated for 3 because there is some case for 3. I'll try it again. So it is I have to do df1 by dx plus df2 by dy plus df3 by dz. Now, if it is df1 by dx, then it is x divided by x square plus y square plus z square to the power p by 2. Original is r vector divided by magnitude of r to the power p. Now, if I do keeping the numerator first, so x, and then doing the differentiation, then it will come as minus p by 2. This p by 2 will go up and it become differentiation will become minus p by 2 multiplied by 2x. So it will become minus px square. This is better word. X into minus px square. So it will become minus px to the power 3 minus px square x into minus px. So it will become minus px square. Now we will keep the denominator and differentiate numerator. It will come as 1 by x square plus y square plus z square to the power p by 2. So net is minus px square divided by x square plus y square plus z square p by 2 plus 1 plus 1 by x square plus y square plus z square divided power p by 2. If I settle it down, it becomes minus px square plus x square plus y square plus z square divided by x square plus y square plus z square to the power p by 2 plus 1. Now, if I take df2 by dy plus df3 by dz, then whole term will become minus px square minus py square minus pz square plus 3x square plus 3y square plus 3z square. It would settle divided by x square plus y square plus z square to the power p by 2 plus 1. If that is the case, it will resolve in now x square plus y square plus z square, x square plus y square plus z square, and in braces 3 minus p. Now x square plus y square plus z square, if I settle it down with the denominator, it becomes 3 minus p divided by x square plus y square plus z square p by 2 back. So that is the divergence of r vector divided by magnitude of r to the power p. 3 minus p divided by x square plus y square plus z square to the power p by 2, or 3 minus p divided by magnitude of r to the power p back. This is a divergence of a vector r vector divided by r to the power p. So we used, this is the algebraic way we use to calculate the divergence d for the vector field capital F equal to f1i plus f2j plus f3k, df1 by dx plus df2 by dy plus df3 by dz, that come as 3 minus p divided by magnitude of r to the power p. If p equal to 3, then divergence is 0. So if I keep a charge at the center and whose the vector field is r vector divided by magnitude of r to the power 3, when r to the power 3, then divergence is 0, even though I get the surface integral. I'll get the surface integral. Anyway, anyone calculate. Can someone try it? Calculating the surface integral when vector field is r vector divided by magnitude of r to the power p to the power 3, then it will become r vector divided by magnitude of r to the power 3. If I want to calculate the surface integral, that is flux, if I have divergence, then divergence dv, integration along the full volume, that will give the surface integral back. The equation of surface integral is capital F vector dot dA vector, integration along the surface is surface integral. That is same as divergence. Divergence integral over the volume, and integration is for the full volume. Same thing, because the surface integral divergence is surface integral by the volume. Volume is d delta v, where v tends to 0. If volume I keep on the right side, take it right side, then it becomes divergence dv and integral over the full volume. If I have divergence as 3 minus p or 3 minus p, if I have a divergence as 3 minus p and r to the power p, 3 minus p r to the power p dv, then divergence will be 0 when p equal to 3. Then the surface integral through this way calculation, divergence of p dv volume integral will be 0. Whereas let's calculate through the geometric way. The divergence is capital F vector dot dA vector, capital F vector dot dA vector divided by the volume. So capital F vector is r vector divided by r vector divided by r to the power 3. 3th case we are taking. Now since it is radial everywhere, so dot product is not required. So r vector divided by magnitude of r, that is a, that is actual radius of a sphere, a to the power a. So a to the power 3 and then 4 pi a square, that is the full surface. Then it becomes 4 pi by a. Dot product means numerator is r becomes a. So a by a to the power 3 means 1 by a square into 4 pi a square. It becomes 4 pi. Now surface integral through geometric way is 4 pi, whereas surface integral through algebraic or Cartesian way, where we have divergence as 0 and then dv is 0. Why there is irregularity? Why it is not homologous? Why it is not kind of analogous? The case is that vector field is not defined. Vector field is not defined at the origin. R vector divided by magnitude of r to the power p. So if I take to the power p or to the power 3, then x, y, z is 0 at the origin. Something divided by 0 is undefined. So if vector field is not continuous inside the full region, then you cannot apply divergence fundamental. So surface integral by the volume is the better calculation for the divergence. You cannot go with the df1 by dx plus df2 by dy plus df3 by dz. That is only if vector field is continuous full inside the volume. Then only you can go through that way. But still, if it is continuous, can you think that this gives a kind of respite while calculating the surface integral? If vector field is capital F, vector field is capital F, and it is equal to x square plus x square plus y square I plus y square plus z square j plus z square plus x square k. That is the vector field. Now calculate the surface integral of this vector field if this at the origin, at the origin, the surface integral when this vector at the origin, can you calculate the surface integral? Means this is a kind of vector at the origin. I'm sorry, the vector field is x square plus y square I plus y square plus z square j plus z square plus x square k.